This is Brian Putt. This is part 2 of this BOI analysis of whether we should buy a new or a used car. In the first video, we framed the problem, and we talked about different strategies that we could follow if we bought a used car, as far as getting a mechanic to look at the car and tell us how much it might cost. And in this section, we're going to actually get into the model, and we'll develop a number of graphics. So just as a refresher, this is the influence diagram. We are going to be using Enterprise 4.0 SIPmath today. In using SIPmath 4.0, we have the option of having multiple PM tables. In the free version, you just have one, and there's a lot of flexibility. You can do an awful lot with the free version. But with the Enterprise version, there's more that you can do. The way we're going to structure this analysis, we have a model in Excel, and it has in there all of the decision policy variables. We will then look at all the strategies, and there'll be a separate PM table for that. And in that strategy table, we'll talk about the decision policy. It gets information, the car, if there's no information, the quality of the information, and the decision policy for low, mid, and high indicators from the mechanic. So now let's flip over to the Excel model. Okay, here's our model to evaluate whether to buy a new or a used car. And in this model, we have default values for a decision policy that's going to be based on the strategy table. Whether we get information, what type of car we get with no information, what type of inspection quality, and then we're gonna add a variable here, which is the probability of low repair costs. And we're going to do something a little bit later with that uncertainty as I test it. Then we have the decision policy. If we do get information, whether we used used or new. Okay, these are the defaults. We have the repair costs are broken into 3 categories. Let's scroll down here a little bit. There's a low, mid, and high repair costs. And when I add these 3 together, probabilistically, this is the curve that I get. Okay? And it has a value of 58 as the average repair cost. We have the price of a used car, $35,000, new car, $39,000, and then here are some calculations down here that pick up the cost of repair and the base price and the total cost. So here is the total cost of the car, $38,758, which if I get a used car, which I think is the reference case here, it's equal to the $35,000 plus this $37.58. Okay. Now, if I wanted, let's just bring this chart up here. So if I wanted to say I wanted to get a new car, what would you expect? So I put a new car in there, and now it's $39,000. Okay, or I could say I want to get information. And now it goes to 38,809 and 908. But let's see. Oh, we always got the used car, so this should actually be whatever the cost of getting an extensive is, which is 150 more. So maybe I don't want to get the used car when it's a high cost, so I'll put in new there. Oops, I guess that needs to equal to this, right? And just copy that up there. And now we're down at 38,295. Let's go back and put used here again. Okay, there's 38,907. And if I put new in here, I improve it 38,295. I could put new in here. And now I'm at 38,308. So clearly I could run through all these different combinations, and I could do copy paste and and get all the results and then make a decision, if you will. But let's do it a different way. Let's assume we have a strategy table that could have several alternatives to include all the decision policies based on information. So I've already set up a strategy table here that talks about 6 different strategies, 1 through 6. The first strategy, let's center those. The first strategy, it's called Decision Policy 1, is a new car with no information. Policy 2 is use with no information. Then Policy 3 looks at perfect information. Yes, I get information perfect, and I has this policy of use new new, and then the next to it is use used new. So I'm picking up the mid cost with the used vehicle as well. And then I went into imperfect information with extensive reviews. And then over here, because we're going to calculate some value of information, I want the optimum reference, which I'll determine based on the best of these two, and the optimum with information, and then I can calculate the value of information. So how am I going to do this? Well, first of all, I'm going to use multiple experiments, and when I do multiple experiments, I want to make sure I have a blank PM table. So I had already archived the model PM table, and now I need to go back to this blank one. I'm going to do that using this Save PM Table icon, and I will go back to PM Table, and I'm going to retrieve that, come back to my strategy table, and what I will do is, let's see, I need to link. What's happening here is there's a variable here that's going to run from 1 to 8, and it's going to pull these variables based on whatever this index is. So index 2 is here. I'm going to make that I'll make that a 3, okay? And so now it uses used yes, perfect, used new new, right? Now these variables need to tie back to my model. So let's do that. So the model decision policy equal to the strategy to get information. Link the other variables. And for the probability of the low repair costs, we'll just use 45%. We're ready to do our multiple experiments. I've got a blank PM table over here, got a strategy table. I'm going to, the multiple experiments is going to change this value from 1 to 8, and I have to tell it the value measure. Oh, my value measure. Let's see, the value measure is total cost. Let's check that one. So it comes back here to this car cost. So let's give it a shot here. We're going to come up here to SIPmath, define outputs, multiple experiments, and here we want a name. Now we're going to, remember I mentioned we're going to have a strategy table, we're going to have a tornado, we're going to have some sensitivity. So let's just call this strategy. Okay. Output cell is this cell here. The input name, I always just use ME. We need something in there. The input cell is going to be this 3. And the input values are the 8 cases that I want to run. And I need a place, I'm going to put my spark lines simply so I know where they are. I'll put them here starting, so I'll have spark lines across this way. So we'll say OK. There are our cases. And what we might want to do now is to get the average of those cases. Copy that across and get stats. So now we see for our reference case, optimum reference case, getting the used car at $38,758 is less expensive than $39. Therefore, the reference case here is going to be defined as this. Oh, I wanted to paste formulas, didn't I? base formulas. And the optimum with information. Typically, the optimum with information would not be perfect information because we can't really get perfect information. And we can see that perfect information at 37,731 and 37,803, these are both less than the imperfect, which is what we would expect. So in this case, the optimum with information is the best of these two, which is option 6. And that's what we have in here. So now I can calculate my value of information. My EV value of information is equal to this number minus my optimum reference. We are trying to minimize costs here, so we need to come up with a sign convention. I would rather think of value of information as being a positive thing. It's going to help me. So we're going to put a minus sign in front of all that. And then we need to hold this constant at 4 and copy that across. Value of information against itself is 0. And what we see is the maximum value of information we can get is 463. So I guess it's looking here for the probability of a new car. So let's put in, well, if I get a new car, that's 100%. And a used car is 0%. And if it's perfect information, what we want to know is how often do we get the new car? SIPmath, chance of success, chance of whatever, that this variable here is equal to what? The target value is going to be 39,000 because there's no cost for getting perfect information. And we did that because we want, in doing a VOI analysis, we always want to understand is there value with perfect information before we go to the effort to get imperfect information. So let's see what this answer comes out to be. 58, that feels right. In fact, what we could do here is we could plot that if you wanted to. SIPmath graph. And so we see there's a 59% chance of having 3,900. That's, of course, well, it says 58 here now. I thought it said 39. So now over here, SIPmath, chance of success, output variable is here. Excuse me, it's equal to 3,900. That's only 16%. And then over here, for these two, it's SIPmath, chance of success, chance of whatever. Output variables are here. And it's equal to, now in this case, it's going to be equal to 39,000 plus the 150 for the inspection. So it's going to be 39,150. Oh, let's do something else here. Let's plot these two, which would be a comparison of our reference case and our best VOI. So I'll highlight those. SIPmath. We generate the two CDF curves and then combine them so we can look at the two charts together. So we can see that this difference here in the expected values, it corresponds to my 463 in the VOI. Let's do one more thing. What I'd like to do is I'd like to add in insert an uncertainty, so a risk. So let's look at standard deviation. Okay, this is the uncertainty, if you will, of the cost. And then what I'd like to do is I'd like to do a cross plot of the cost of the car to the standard deviation. This is kind of like a risk return chart. So I'm going to plot these first 6 because 7 and 8 correspond to one of the others, right? So we'll do insert cross plot. So now in analyzing this chart, we're trying to get down to this quadrant here. So just to remind ourselves, let's put a good down here. And by the way, if you select the chart and then put the text box inside it, the text box will stay with the chart. So if we want to be down here, there's no reason that I would ever accept this option to this option. Oh, but let's do one more thing. Let's add some data labels. And so now, these are both perfect. These are the ones we wanted, but those are both the perfect information. We said we can't get perfect information. So we really need to pick amongst these others. And clearly these two are better than this used. And the new is good on the risk, but pretty high on the cost. So now it becomes maybe between these two. We can see that this one here, which is the U-end, option 6, is the lowest cost, but it's got a higher standard deviation. So depending upon your risk preferences, you may choose to go with the imperfect new, which also, by the way, has a 56% chance of a new car versus only a 20% chance. So to be very honest, even though we said that 6 was the best option with the lower cost, I think I would probably go with the 5 based on my own utility. So we've kind of completed the strategy analysis, but what we might want to do is store away this PM table as strategy. So what I'm going to do is I'm going to come up here to save PM table, and now I'm going to archive this, and I'm going to call it strategy. And when I do that, it relabeled this worksheet as PM table strategy, and it generated a new PM table, which I can then use for the subsequent analysis, what we're going to do, which is tornado. And we'll do that in the next video. So please watch the next video and learn more about how to use Enterprise 4.0, available from probabilitymanagement.org. Thank you.